Hey everyone, how are we doing? We got Tiffany here and Cece here. Chapter 7. We did chapter 7. It was due last night, right, Cece? Chapter 7 was due last night. See, Tiffany's got a question on the amusement park. We're gonna hop in here to some amusement park. Let's make sure Mewbot is awake. Gonna wake up Mewbot. Mewbot, wake up. He revived himself yesterday. We got Mewbot back awake. The amusement park has opened a new roller coaster. It's so popular that people are waiting up to 3 hours in line. Starting from a randomly selected individual. So this one right here is going to have a lot of randomness to it. And we're going to do some amusement park roller coaster stuff right here. Let's get the amusement park roller coaster loaded up. And there's a lot of good versions. Hey, can we do some of question 1? I'm forcing for homework 5. You bet, Cora. We can do that one next right here. CC, do you want chapter 7? That was due last night, right? So we could do that. We can always got a lot of things. And thank everyone for being here. Sorry, I get started like 4 minutes late. No, we didn't get started late. We didn't. I'm grabbing a little lunch between class right there. Sometimes I go a little longer on the examples in class, and then I grab a little lunch so I can take a moment. Let's see right here. Getting the amusement park stuff loaded up. Loading up. Here we go. It's up in the background. Almost here. Chapter 10, Quiz Amusement Park. How is everyone doing today? How is everyone doing? Mewbot's awake. 100 points out there. A little chill music. Questions loading up in the background. Can't see because I'm blind. And amusement park. An amusement park, roller coaster. Time to do this. Let's check this out. Here we go. Stat 201 amusement park roller coaster question, chapter 10. An amusement park has just opened a new roller coaster. It's so popular that people are waiting 3 hours for a 2-minute ride. Concerned about how patrons who paid a large amount to enter the park may feel about this, they survey 100 consecutive people as they exit the park, starting from a randomly selected individual. So they're going to talk to 100 people in a row. What kind of sampling is this? We should identify this very quickly. Is it A, B, C, or D? There's no letters on these. But a simple random sample is when you pick numbers randomly, or you give everyone a number, pick those numbers randomly. A census is when you talk to everybody. A convenience sample is when you reach the easiest people to reach to. And a systematic sample is when you take every kth observation from a random starting point. So which one of these is this? Who knows which one it is? We'll pause here for a moment. Good practice right here to understand these terms. Yep, this one will be different. This one has a lot of randomness on how it's done. So listen to the definitions again and see which one mine is, and then figure out which one yours is too. A simple random sample would be everyone gets a number. And so, because this one will be different. This one changes every time we do it. So this one will change every time we do it. This one has a lot of different variations in how it's done. So, because the question here changes each time. So this one right here, we have the 100 people are taken in a row. Now, is that a simple random sample where everyone is given a number and we select a random observation? Is that a census when we talk to everybody? Is that a convenience sample where we reach the easiest people to get to? Or is that a systematic sample where we talk to every kth observation from a random starting point? So what would this be right here? What would this be? Which one of these is this? Which one would this be? It wouldn't be a census though, because a census would mean we talk to every single person in the park. So we are going to speak to 100. Good job right there, Tiffany. Good guess. It will be a convenience sample because we're reaching 100 people really quickly and really easily. So we're just going to say, let's talk to the 100 people right there, and we'll get the data from them. We could try. We'll try. We'll do one more version of it after this, and I think we're going to do the 474. So we'll see which version we get next and check that out. So this is going to be a convenience sample right here. So this is going to be a convenience because we have right here the 100 people we are trying to reach immediately. A census would be talking to everybody in the park. What is the sampling frame? Now, what is the definition of a sample frame? What is the definition of a sample frame? Let's go to the notes we have from today. A sample frame are going to be the people we have access to sample. Very important right here to know when you're talking about your sample frame, it's going to be the people you have access to sample. So who would we have access to sample if we're talking to the people who are leaving the park? Just think about these are the people who we could possibly talk to. Would it be all patrons who are willing to wait in line for the roller coaster? That doesn't have much to do with leaving the park. All patrons who like roller coasters? We're talking to ones that are leaving the park. All patrons who go to amusement parks, all patrons of the park. So all the patrons of this park are the ones who could leave this park. Does that make sense, Tiffany, right here, that anybody, yep, great answer right there. So all patrons who are leaving the park. Now, be very careful on this question because this changes. I want to point this out to everybody right here. This question has a lot of variation in it in the ways it could be presented. It literally has like 20, 30 different versions of it. You have to ask yourself, we are speaking to people as they leave the park, so we could theoretically speak to anyone at this park. Does that make sense? Like, the sample frame is anyone we could talk to. So if it says they're talking to people from the line, you could speak to anybody who's willing to be in line for the roller coaster, hence for there. So if it says you're talking to people in the line, then you could theoretically speak to anybody in the line. Is the sample frame likely to be representative? We got some convenience bias right here, so I'm a little bit worried. No. Let's look at the no's. No, the sample frame is not likely to be representative of everyone who waited in line for the roller coaster. I think it's going to be that. I'm a little worried on this one. No, the sample is not likely to be representative of everyone in the park. This is it right here. So everyone who waited in line for the roller coaster. They better go with that because I can tell you reasons it wouldn't. I'm a little worried on that one. They're taking convenience sample. You shouldn't sample 100 consecutive people as they leave the park. That's not representative. Convenience is not representative. And it's between A and D on that. Which members of the population of interest are omitted? The patrons who are not willing to wait in line, patrons who exit the park at a different time. Yeah, we're going to get people who exit the park at a different time. So now I'm starting to wonder. This is the only one I'm really worried about. Oh, limited choices make it tough. So on D, no, the sample is not likely to be representative of everyone in the park, representative of everyone in the park. Because people may exit the park at different times. It's either A or D on that. Ooh, my Pearson. Yeah, because we're not sampling the line. I think that's going to be it. That was a tough one right there. So looking down here at this one, because the big issue with talking to 100 people as they leave the park is you're only sampling from that time frame. So then we're not going to get a representative view of everyone in the park, because let's say you go in the morning, then the views you get from people as they leave the park are going to be people who probably just didn't want to be at the park. So that's not representative of everyone in the park. We are trying to understand the roller coaster, and that's where they almost tricked me, but that was a tough version. We'll do one more version of this one right here. A lot of versions possible on this. Okay, let's see right here. An amusement park, blah, 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 all this good stuff. They survey 150, same version. I'm not going to do that again then. They survey every person as they enter the park. Okay, so they survey every person as they enter the park. So what have they done right here? They're going to talk to everyone as they enter the park. This is a census. So this will be a census right here, 100% a census, because they've talked to everybody. That's what a census is. What is the sample frame? These are the people they could speak to. So they could speak to anybody who goes into the park. Now be very careful. It's not always the same answer. The sample frame is going to be anyone they could speak to, and they're speaking to everybody, so they're going to speak to anyone who goes to the park. Is the sample likely to... we could try to find it, yep. So is the sample likely to be representative of the population of interest? I would say yes. So the population of interest is people who go to the park. Concerned about how patrons feel about this, not just people in the line. They want to know about the people at the park. The population of interest is everyone who goes to the park. Does that make sense? We don't want to understand people who wait in the line, which we might be sampling from at some point. We want to understand people. We want to understand the people who go to the park. So is this representative of the population? Then we want it to be representative. So I don't even think this could ever be an answer, because we're not trying to understand the people who wait in the line. We're understanding the people who go to the park. Does that make sense, Tiffany? That's a good help right here for this one. I don't think it can ever be these two. So I don't think it can ever be these two whenever you do this question. I'm pretty sure there's no version where these are the right answers, because the population of interest is always people who go to the park. So either you're representative of the people who go to the park, or you're not representative of the people who go to the park, because you're not trying to understand people who wait in the line. We might get views from the people who wait in the line, but we are trying to understand people who go to the park, and we either achieve that objective or we do not achieve that objective. That's kind of a good hint for that question right there. What members of the population of interest would be omitted? No members would be omitted because we did a census. I think we did it. Got it. Let's try one more version right here. Good, tricky question. We'll try one more, and we'll come back if we don't get it this time. Here we go. This is a good version right here. Every 10th person in line. So once again, there's so many versions of this question, but this one might help out. This one's more similar to yours, but do remember to read every detail of these questions. So Tiffany, this might help out with your version right here. Once again, there's like 30, 40 versions of this questions, a lot of different ways they can word it. Look at how similar mine is to yours right here, but notice they added in something else. Mine says they're talking to every 10th female in line for the roller coaster. Does that make sense, Tiffany, right here? This is saying every 10th female. So is this A, B, C, or D? This is similar to yours in this part. Is this A, B, C, or D for the top question, which doesn't have letters next to it? Is this A, B, C, or D for this version right here, where it says they talk to every 10th female, which should be from a random starting point? They go to the line, we're going to say we're going to choose a random time to go to this line. We're going to talk to every 10th female in the line. So which would this be? A, they talk to everybody in the park. B, they talk to the first people they have access to in the park. C, they start from a random point, and then they choose every kth observation. Or D, they give everybody a number of sorts and they pick randomly from those individuals. Those are the definitions for a census, a convenience sample, and a systematic or a, yep, so this would be systematic. Great job right there, Kayla. This is going to be systematic right here. It's just that you'll see that that'll matter here towards the end. What is the sample frame? Now you have to be very careful right here. A, B, C, or D. Do they have access to all the females who go to amusement parks? Do they have access to all the patrons willing to wait in line for the roller coaster? Do they have access to all the female patrons willing to wait in line for the roller coaster? Do they have access? Remember, the sample frame are the people they have access to that they could theoretically sample. Do they have access to all the female patrons who like roller coasters? Which of these are the people that they would have access to sample? So that's what a sample frame is. That's one of the key definitions that people usually make a mistake on. It's the people they could theoretically sample. Great job, Tiffany. So they could theoretically speak to any female who is willing to wait in line for the roller coaster. Yours will be similar to this. I think you can get it. I think you can get it from here. And remember, this one incorporates females in here, so it's a little bit different because there's a lot of versions of this. And so now, is the sample frame likely to be representative of the population of interest? Remember, once again, we're not interested in the people who are waiting the line. We want to understand the people at the park. They're interested in how their patrons feel about this, not just because it's patrons is the population of interest. So I would say, no, this is not representative of the patrons of the park. That's the population of interest, not the people who are waiting in line. Even though we might be sampling from the people who are waiting in line, we want to understand the patrons at the park. So I would say this is not representative. And what bias do you think they have? Who remembers the key term? We have probably done what to a certain group right here. Good term to remember from your flashcards. And we'll head over and do some first before. And we could come back to this one. What group do you think we've had a problem with right here? What do you think we've done? So no members of the population of interest are omitted. So that'd mean no bias. I'm sorry, amusement park employees, we're not interested in you. We're interested in patrons. So that has to be wrong because we're not even interested in those individuals. The patrons who are not willing to wait, who are willing to wait in the line, are they omitted? Well, they're willing to wait in the line. Well, so the patrons who are willing to wait in the line would not be omitted. It'd be the patrons who are not willing to wait in the line. And it should maybe mention like people who are not female would also be omitted because we want to understand all our patrons. So this basically says which group are we leaving out and not having access to. So by only speaking to, hints for your question, by only speaking to people who are waiting in the line, we're not going to get a representative sample because if we're asking people, do you like this ride and do you think it's a good ride? Well, they're willing to wait in the line. So by speaking to people willing to wait in the line, they're going to be biased towards an answer. So that's going to cause some sort of bias, and we're going to have under coverage right here of people who are not willing to wait in line. I think we got it 100% that time right there. So this is actually one of the best questions to practice. It does a lot of different versions right here. So we go here. The survey goes every 15th person in the roller coaster line, starting from a randomly selected individual. Ooh. So this is once again a systematic sample. Who are the people we have access to? Only the people who are willing to wait in the line are the ones we could speak to. Is this going to be representative? No, it won't be representative of everyone in the park because the patrons who are not willing to wait in the line, we have omitted. So we have omitted those people. Once again, these answers change. So Tiffany hints for this right here. But these answers change, and you should practice this one because it has so many different versions of it to make sure you catch the small nuances between a census, a simple random sample, a systematic sample, a convenience sample. Is it representative? Is it not? You bet. We'll come back here and we'll do that one next right here. Let's head back over to the main screen. Great job. Tiffany, great job working ahead right here. That is such a good question to practice right there. We'll come back here. Cora's question next. We got here. CC, did you want chapter 7? We did chapter 7, so that's why I'm like double checking. CC, put that you want chapter 7, which question? And we can go back and do that. Chapter 4. Great job, Tiffany. Excellent work. Did you know? Some of these videos are getting like 700-800 views. Tiffany, thank you for all the questions because people are using them to review and making some great grades. So I was looking and like literally the last few office hours getting 700-800 views. It's pretty crazy. But people are using them, which is what we want. And Tiffany, thank you for all the questions because they're basically they're able to review what you're asking, which is really helpful. And so yeah, feel free to ask a specific one here, and we can do that here in a little bit. We are about to do some 474. Hopping in here. Let's take a look. Okay, stay tuned for some data mining association rules, I believe. Okay, let's take a look. The question was 474. Question number 1, homework 5. Let's go take a look at 474. Question 1, number 1. 474. Time to check it out. Okay, so we're doing some data mining right now. I believe market basket analytics. Homework 7? Sure. Association rules. So for this assignment, some of the output will be awkwardly formatted. We always love that. The assignment, music likes mod. CSV contains information on the Last FM, an online service that streams music. Awesome stuff right here with all the playlists with Katy Perry. Perfect. In this data, which comes from 2011. So think of the music back then. 1,821 carts. Yeah. The one where you do jump. Yeah, we can do some jump output. You got it, CC. We'll do that. I'll find one with some jump output that we have to use to solve. We can practice reading jump output. My ear's just gonna be stupid today. Oh my gosh. Okay. So what is the point of this right here? What are we doing? This is market basket analytics. I don't have read. Oh, no, not reads. I don't have A rules loaded in. So the reason this didn't work is A rules was not loaded in. A rules has the read transactions function, which is going to read the transactions. This is how everything is separated. And let's read it in. This is transactional data right here. So rather large data set right here with all the individuals. Just taking a look at the list right now, it looks like. But this is every single person right here. We already have this in. I didn't download those. Can you do that? Okay, good. So this is the item frequency plot. I don't like to look at it this way. I prefer to look at it this way. Does anyone have a favorite like 90s or 2000s band? Someone put your favorite 90s or 2000s band in the chat right here, because here's all the 90s and 2000 bands right here. I better watch it. I don't even know what the names. These are lesser known bands. So like Hoobastank and Horse the Band. All these bands right here. Hilary Duff. You remember Hilary Duff. 8% of people are listening to Hilary Duff. High School Musical only at 1.3% of people having that in their playlist. Does anyone have High School? Yeah, Cora knows High School. These are random bands from Last FM, so I'm like, what will appear? Let's go over here and look at some Ben Folds. Only 1 in 180 people have Ben Folds. Anyone have a favorite artist? Like if you're like, No Doubt. 2.6% of people have No Doubt. It was me. I was the 1% right there. Do you have another favorite band, Core, that we can look at? And what are we looking at right here? We're looking at the item frequency of what people have in their carts. So you could go right here and go to, we want to go to inspect. We're just taking a look at what we've brought in right here. These are the first 5 people's playlists. So here, let's just look at the first person. The first person's playlist has ABC, Air, Caf Del Mar, Coldplay. Gotta have some Coldplay. Daft Punk, Depeche Mode, Dido. Remember Dido? Duffy? Don't know who that is. The Gorillaz, they're awesome. Who else? Japan, they've got all of Japan in here. Ice House, I think we're the Moby. Can't forget Moby. Madonna, Lady Gaga. Some other bands right there. Talk. So Fountains of Wayne. Let's see if Fountains of Wayne is in here. Fountains of Wayne. You have to make sure it's spelled correctly. It says N-A. Oh, no Fountains of Wayne. It might be in here. A, B, C, D, E, F. Fountains of Wayne. Oh, sad day. Fleetwood Mac. Let's go look for Fleetwood Mac real quick. Fleetwood Mac. What? Oh, I don't have these as square brackets. Square brackets find positions. Curly. 2% of people listen to Fleetwood Mac right there. Sorry, Cece, no Fountains of Wayne. It's a bummer right there. Maybe it's Wayne of Fountains. Wayne Fountains of. I don't know. Things can be interestingly put. If you look, there's no spaces, so we have to be careful when we're looking up bands right here. And inspect right here is a very important thing with the transaction data. Whenever you're inspecting things, it'll print the output. As we've said a bunch of times, and please repeat this to yourself, do not put the square brackets outside of the inspect. How many carts am I about to display here, Cora? With the way I've written this, how many, and what do we mean by carts? These are playlists, like almost 2,000 playlists of individuals, which is a cart. Like I have my playlist, and so I'm a cart. I have who I listen to. So how many will I display when I run this code? Do not be tricked by this. I will be displaying all of them. So we'll just let that do its thing. And then this is actually the output you get from the bracket 1 right there, which I guess would be this. Oh, it's mad. It doesn't like that. If you want to display the first cart only, do that. If you want to display the 200th cart, which is me, there's my music. Listen to some Beatles and the Doors. Man, this person likes some old school stuff. It's me. Asking Alexandria, AC/DC. This is a 70s person right here. Listen to some Coldplay. Led Zeppelin, Pink Floyd. Yeah, this is all, this person 200. You can see the connections between like the Doors. I have no idea on some of these bands. Slipknot. So they're into like grunge and metal and all these things right here. Pretty interesting playlist. The Devil Wears Prada. This is a band. So all this stuff right here. Martin L. Gore. Don't know of these. System of a Down, know of that one. Okay. So there are 2,459 unique bands. And we could actually find this out pretty quickly right here if we go to item frequency and go to music, which is going to give us the frequency of all the bands, but let's go to the length of the item frequency vector, just showing that we could find this because this is how many things are in there. So that's how many there are. I'm having a burger while watching. Oh, awesome. So good to see you, Colin. Man, I want a burger. I still got one left. Maybe I should make that for lunch because I can't make 2 burgers. So I might just take it myself. I can make some jalapeno cheddar sliders. Be good. Back in 2011, some of my favorite bands were The Cure, Rush, and Pink Floyd, and Dream Theater. What fraction of the 1,821 listeners like The Cure? Now, this is also known as support for Cure, The Cure. Please note the way it's spelled. It does not have spaces in it. Very important to see that. Well, I'm a big fan of Coldplay. To find out what percent of people, so this is just an example question. So to find out, example question 1 right here, to find out what percent of people like Coldplay, I would go right here and I'd have to look at the what. How would I look at the frequency? I'll put 10 minutes on the clock. We'll do 10 more minutes of this. How would I look at the frequency of people who like Coldplay? How would I go and look at the frequency of people who like Coldplay? I'm not going to do the question asked. I'm going to do my own. How would I look at the frequency? We're going to look at a fraction, item frequency right there. Great stuff. An item frequency puts out a vector, puts out a named vector. We want to look at the item frequency for the music, and we could simply take and put square bracket next to it and put Coldplay. So now it gives us the item frequency for Coldplay. This is 18.1% of people have Coldplay in their playlist. So now if we want to know how many people, well, we'd have to ask, we could go right here, another example question. So instead of getting the percent, which you could just times this by 100 to find the percent. And so that's the percent of people who listen to Coldplay. No, probably the grader might get confused. It's still the same answer. But now we would need to know, think of this, 18.1% of people listen to Coldplay. If I want to find out how many people there are, I should what that by the what. So try to figure out, if I want to find out, like, just think of what we've done right here. We have a whole bunch of lists that people have of what music they listen to. 18.1% of these people listen to Coldplay. So I should blank this by the blank of that list of individuals to find out how many people. So to find out how many people listen to Coldplay, because I know 18.1% of people listen to Coldplay, so then I should blank that by the what of that list of people who listen to Coldplay, or of the list of music. Yep. Cora, you got it. Great job, Cora. 100 points right there. That's exactly it. We're going to multiply by the length. So we're going to multiply by the length of how many observations there are. And there we go. 330 people. And so 330 people, which we could double check this by, once again, the length is this, and then we could just check the mathematics. 330 out of this is this. So just making sure your mathematics works is kind of key right here to be like, okay, 330 playlists have Coldplay out of the 1,821 playlists. You can also see the length of it. Oh, I thought it showed it over there. Apparently it doesn't. Is it not? There it is right there. So there's the length right there of it. That might be how many bands are listened to out of the 1,822. And I got an extra one in there. That is weird. And then this is the amount of bands right here. I don't always look at it that way. The length of it is how many playlists there are. So it's a cart. It's weird to think of it as a cart, but someone's just putting bands into their cart. And so that is the length right there. Use the atom frequency from the previous question. What fraction liked at least one of Rush or Pink Floyd? So we want to find the people who like Rush or Pink Floyd. Now, I want to find the percentage of people who like, let's say, Ben Folds or Coldplay. And you have to be very careful right here. When we want to find the percent of people, there's a few ways to do this, and let's talk about this mathematically here. We're going to need a drawing right here to help understand what's going on, because we're about to do a little bit of probability. So tool 1, this is your next chapter. What we're talking about right here is the probability of A and B, or A or B, excuse me. So we have here band A, really? There we go. Band A and band B. So when you think about this, when you add together the probability of A and you add together the probability of B, what will happen? This is good mathematical theory right here. What will happen right here as you add together the probability of band A and B, or B, excuse me, should be or. Good mathematical theory. 201 gets into this a little bit. What is happening right here as you add together the probability of someone liking A or B? So you say like, let's say right here, 20% of people like this band and 24% of people like this band. So would 44% of people like A or B? Would 44% of people like A or B? Just think about this mathematically right here and visually. Would the answer be, well, then 44% of people like A or B? And this is kind of how the answer works. Like, there's something visually going on right here that's going to be a problem that we can fix pretty easily. And we'll do it in R in a moment. But this explains the theory behind what we're about to do. And so, well, then so the probability of liking A and B would be that you have to like both. And that would be this portion right here. That's the probability of liking A and B. So this right here is the probability of, this is the probability of A. I always get these wrong. That's B. And I always forget if it's called union or intersection. I always forget the words for that. That should be mathematically, please, there's a math major and you say, Brian, you should put the U symbol. That stands for probability of A and B. That's the way I read it. It's the easiest way to remember it. And so that's where they connect. That's where someone likes A and B. So the issue is we wouldn't have 44% for any of these answers. Because right now, there's an overlap. Do you see the green overlap? So what should we do? If we add together the probability of A and we add to it the probability of B, how can we fix this error? How can we fix this error? Do you see how to fix the error, Cora, where we're going to have this overlap? So how could we fix this error right here? So now if we add together the probability of A and B, we're adding that area twice. So this area is going to be added twice. So how could we fix this? So how do we mathematically fix this problem right here where we have the probability of someone liking A or they like B? We have to remove the middle part, so we'll subtract. Because of this, we're going to go right here and go minus the probability of A, and then I say and B. Some math major is going to say, that's the union, the intersection. And so this right here is the probability of A plus the probability minus the probability of both occurring at one time, that they like A and B, I always say. That's just an and right there to me. So we have to remove that middle part. So this is a little bit of probability theory right here. The best case scenario you can be in, I wish I could move the drawing really quickly, is a scenario like this. Tell me if 4% of people like this band and 3% of people like this band, what percent of people like A or B? Just visually, the way I've drawn this small example right here, if 4% of people like this band and 3% of people like this band, then what percent of people like A or B? And this is more of a Stat 201 thing that we do, because we only get into this with Stat 201. So Stat 201, this relates to your class with probability, and what would be the probability of liking A or B for that mini example I drew right there? It'd be 7%. Kayla, great job right there. Excellent work. And why would that be? It's because there's no overlap. There's no overlap between these, and the two events are disjoint. So since there's no overlap, they're disjoint, they're mutually exclusive events, and you can just easily add together the probabilities. So the way you're seeing the big example is more of a complex way where we have to subtract off the intersection, I think it's called, the connecting between them. So if there is a connection, we have to subtract it off. But if there's no connection, you can simply add them. And what is the condition 201? Great review 201. To add together two events very easily, the two events must be what of each other? Think of this. They must be what of each other? So the addition rule, 201 knowledge right here, is that we can add together two events, like 4% of people like Ben Folds, 3% of people like Smash Mouth, less than Ben Folds. Then we can add that together if the two things are what? Not quite independent, disjoint. So disjoint makes the addition rule really easy. If they're not disjoint, you have to subtract off where they overlap. Cora, good answer right there. Independent will be the multiplication rule for 201. So if they're independent, we can multiply them together. And these are great things to review for 201. Good flashcard knowledge. And we do a little bit of math in chapter 12 coming up next week. So everything we just reviewed right there goes into this question. So if we're trying to figure out for this, the percent of people who like at least one of Coldplay or Ben Folds, well, we need to figure out probability of A is probability of Coldplay. Probability of B is Ben Folds. And then here's where people get stuck. We need to figure out the probability of A or B. And I might do this as a subset. Can I do it? I might be able to do it with a which. Let me go to subset. Subset people who of the music items, and this is the condition. Items equals no. Percent AIN percent. Yeah, what part of the homework we're doing? Question number 1 right here. Question number 1 for 474. And then we want to go right here and we want to go to the vector. So percent AIN percent means that they have to have both of these. So what am I finding here visually? Awesome stuff. What am I finding here visually? I am finding, we'll do another 5 minutes on this. Good stuff right now. We're finding right here this intersection where people like both the bands. Does that make sense, Cora? That we are finding right now the intersection. I think I've written this properly. Good. Oh, look at that. It tells me the answer is only 4 transactions. So what I could do is I could take the length of this subset and I want to divide by the length. So let me just show what that is. That's going to get 4. Go away. That's going to get 4, and I want to divide by the length of music, which is going to give me the fraction. So that's C. Or that's AB. We'll call it AB. Okay. Does this make sense visually right here? Could we do a subset and do... Well, so the same answers could be obtained for A. If I were to go back here, and this is a good way to break it down, I could do percent in for Coldplay, and we should get the same answer for A. A is 0.181, and so we should get 0.181 for A. There it is right there. So if you notice, this is going to get the same sort of thing, and we could do it for Ben Folds also. Copied it. And this is going to get the same thing if I put Ben Folds here. It's going to just change it from a named vector to 0.0065. So this is saying A is the percent of people who like Coldplay. B is the percent of people who like Ben Folds. AB is the percent of people who like both Coldplay and Ben Folds. So what do we have to do right here? So this is everyone who likes Coldplay. This is everyone who likes Ben Folds. And these are people who what? These are people who what? So what is this right here, Cora? Like, these are people who like Coldplay. These are people who like Ben Folds. And these are people who what? So AB would represent what? And we drew it out visually here to make sure we see what we're doing. AB would represent the people who what? Like, this is the people who what? Who like both. So what we can simply do is we can just go here and go A plus B minus AB, and that's the answer. Is that exactly it? Might be rounding it, but that looks to be it right there. And yeah, it looks mathematically to be it. That's interesting. Comes out to that. But that looks to be the answer, and this is a good way to go about doing it. Make sure to do it in steps. Make sure to see the components you're creating. It's very important not to think of, I just have to write the whole thing out here. Think, theoretically, what are you doing? You want to find out the people who like this band, the people who like this band, and then you want to remove off the people who like either. Now, I'm wondering, let me see something right here. Can it be obtained? Let me look at something. I don't think percent OIN. No, that means they only have Coldplay and Ben Folds. And, well, there we go. I'm not saying anything, but, yeah. And that means they must have at least one of the two. That was a lot of work. Do you see what I see, Cora? OIN means they can only have those in there. OIN means you can only have Coldplay and Ben Folds. Like, those are the only things you have in your playlist. So if there was anybody, of course, these are what I see too. So there's no carts, no playlist that only have. O means only. And then this means they must have it in there. They must have to be included. Now, they could have both. They could have one. And we're not double counting on this one. Oh my gosh. No, not double counting. And yeah, just kind of pointing out right here. No. So I was just thinking it through theoretically, and I was like, oh, I was going to do that. Good to know what AIN is and IN, and mathematically we showed it, but we also showed this right here. Let's see a tiny bit more right here. We'll look at this next one. How many bands have exactly 80 listeners? I'm trying to think of another way to do this one without doing this right here. How many bands have at least 80 listeners? How many bands have less than, let's say, less than 20 listeners? Less than 50 listeners. Cool. And we can go right here. Now, there's a lot of ways to do this. It's a little less than... I have no idea what the answer is right now. We only consider rules of length 3 with these bands. Use the choose function to determine how many possible rules exist. Okay, so once again, my question is different. Once again, please note, Brian changes questions. Brian often changes the question. Please note that I am changing the question. And when we want to think through theoretically what we're doing right here, and we'll finish this question, then we'll head over. So I think we're going to do more tool on here in a moment. Okay, so with this right here, we want to look at how many bands there are. So how can I look at, so think about this first. How can I look at the percent of people who listen to bands? First thing I probably want to do is look at the percent of people who listen to bands. So how could I go look at the percent of people who listen to bands? How could I go look at that? How could I go look at the percent of people who listen to bands? So I want to be like, oh, let's figure out the percent of people who listen to bands. Let's go figure that out. How can we figure out the percent of people who listen to bands? Like, let's look at each band and be like, well, blank percent of people listen to this band, blank percent, because we're going to only look at certain bands that have less than 50 listeners. Item frequency, again, you got it. Item frequency to the rescue. So we're going to look at this right here. There we go. There's the percent of people who listen to each band. And now we probably want to do some sort of, starts with an L, some sort of what check on this. Like, I'm going to start writing some, so they have at least, have less than. How many bands have, support less than this? Support is the frequency of which people listen to it. So I probably want to do some sort of what with this, some sort of check, but starts with an L. I want to start doing some Boolean stuff. Start doing some, an artist who's not in this band or not in this list. Start doing some what with this. Like, we should probably write some sort of check right here. So we'll get trues and falses. Not logistic, logical, but good guess right there. 50 points. We got the points back today. So we're going to do a logical check right here. And we're going to see if it's less than this, because we can just check a vector. I do like to put things into parentheses. Remember, you can highlight and put in parentheses. Nice and easy like that. And now we've got trues and falses. What can you do to a logical vector? To find out how many things meet this condition right here, what can you do to logical vectors? Because it's just a logical vector right now, so let's find out how many bands meet this condition. They better not all be true. Ooh, I'm a little worried. Oh, there's falses. All those bands have less than 50 listeners? I'm going to look at something while people are doing this. Yeah, a lot of bands have less than 50 listeners. Okay. Just confirming. What could I do to this right here to figure out how many there are? I hate that does not want to do that. What could I do right here to find out where how many trues there are? I want to know how many trues there are. Usually people are between two functions right now. Be careful. One's going to tell you how many. One's going to tell you the percent of trues. So if you have a logical vector, logical stuff is seen as ones and zeros inside of R. So these are just ones and zeros. True is a 1, 0 is a false. So what could I do to a bunch of ones and zeros to figure out how many trues there are? Well, I just figure out how many trues there are. Remember, they're just ones and zeros. That's 1, 1, 1, 1, 1, 1, 1, 0, 0. So what could I do to all these ones and zeros to figure out how many ones there are? I could just what with them? Good practice. Anytime you see trues and falses, you'll be like, oh, no worries, Cora. I might answer in a second. So we have a bunch of ones and zeros from this logical vector. What could we do to all these ones and zeros right here? And Cora, great work. Good practice today. Good practice. What could we do to all these ones and zeros to figure out how many ones and zeros there are? What could we do to all these ones and zeros? So every time you see this, you're like, well, how many things meet the condition? We could just go right here. I'll start off. And we could find the what of it. Because this is just a vector of trues and falses. Trues and falses are just ones and zeros. So we can just add them up, which is sum. Sum is going to sum them up right here, and that's how many there are. Oh my gosh. Woo, that's a lot. It's a lot of things that meet the condition. Woo. So length would just tell you the length of the logical vector, which is how many, this is the total trues and falses. That's the total trues and falses. The mean will tell you the percent of trues, and the sum will tell you how many trues, because it's just going to add together them. So length would just tell us how long the logical vector is. Then, oh, no worries. And then mean is going to tell us the percent of trues, and then sum is going to tell us how many trues there are, because it's just going to add together all the ones which trues are. So we want to do a sum right here because we want to know how many trues there are. And so now the thing is if we have this many trues, well then, if we go and choose from this many, and we say 3 are going to be chosen, yeah, it's a couple like a billion rules. Now the confusing thing, we'll end with this. We'll talk about the choose here for a second. I say to you, I have 3 candy bars, and I'm gonna let you choose 3 candy bars. How many ways could you choose? I've got a Snickers right now, a Twix, and a Milky Way. How many ways could you choose these 3 candy bars? Now be careful, the order does not matter in which you choose them. I'm gonna say you can take any of these 3 candy bars right here, a Snickers, a Twix, or a Milky Way. We'll draw the 3 candy bars on the screen. And you can take any of these 3 you can take 3 of these 3 candy bars. So you've got your 3 candy bars right here. There's only one way. You're going to take all of them. Does that make sense? So here's the thing. No, this is why I asked these questions. So the order doesn't matter right here. What it is that if you have 3 candy bars and I say you get to pick 3 of them, you're getting all the candy bars, which is awesome. So there is one way to pick 3 candy bars. But then what if I say there are 3 candy bars and you get to pick 2 of them? Now, yeah, you're right. So now Cora's on this one. If there's 3 candy bars and you get to pick 2 of them, well, you could pick this one or this one. You could pick this one or this one. Or you could pick this one or this one. But maybe a better way to think about it is you're going to not be picking one of the candy bars. So there's 3 ways you could pick 2 candy bars when I say 3 candy bars, which is the 3 here, and then you get to pick 2 of the candy bars. Easiest way to think about it is that you're just not picking one of the candy bars. So this will return 3 right here when we say there's 3 items, pick 2 of them. This is 3 items, pick 1, which is also easy to think about. 3 items, pick 1 would return how many ways? Once again, we are saying there are 3 candy bars, anything. So you get to pick 1 of them. You will not be picking 2 of them. So how many ways are there to from 3 candy bars, pick 1 candy bar. I say there's 3 candy bars, you get to pick 1 of them. So what would this return right here? We'll do one more example with this, and then we're going to have it to 1 again. Still the same answer, though. So Car's going to be right. It'll return... Oh, I'm on top chat. I got to change that all the time. Muhammad, great answer right there. Muhammad, another 100 points. It'll return 3. Now, it gets complicated if you say there's 10 candy bars, and I say you get to pick 8 of those candy bars. So there's a lot of different ways. If you have 10 candy bars, I'm like, here's a bunch of candy bars. You get to pick 8 of these candy bars. Basically, you're not picking 2 of them. A lot of ways to do that. And here's the ways you could have 10 candy bars and pick 8 of them. So there's 45 different combinations of candy bars people could pick. It gets even bigger as you go towards the center. So we'll see the highest combinations over here. And then it actually gets symmetric on the other side. So I think, yeah, we've reached the symmetry. It's pretty obvious to see if I say there's 10 candy bars and you get to pick none of them, then there's one way. You don't get any of the candy bars. If there's 10 candy bars and you get to pick 1, well, there's 10 ways. You can pick 1 of the candy bars. If there's 10 candy bars and you get to take all of them, well, then there's one way. You're getting all the candy bars. If there's 10 candy bars and you get to pick 9 of them, well, then you're going to take not 1 of the candy bars. So there's 10 ways. We don't expect you to understand it like that quickly, but once again, we do some slow examples with the visualization, and then we go deeper into, well, what's going on. It does create like a golden ratio, which creates, I think Pythagorean worked on this, but it's pretty interesting, pretty fun stuff right here with the way these numbers work if you look at them. You don't have to go that big mathematical theory into it. You have to understand what this function is doing, though, saying that there's 2,177 bands, and you get to pick 3 of them. That's going to create a lot of different ways you can pick them. It's going to cause a lot of problems, hence why we have the a priori learning method. Let's hop back here to some Tattoo 1, put those questions in the chat. We still got 38 minutes in class. For office hours. I don't know what we're doing. Oh my gosh. Question 7, and then we have a question from Tiffany next. Chapter 7, and we're going to do some jump output. Question, or Chapter 7, jump output question. Analyzing that jump output, very important stuff right here. Jump output is very important for the test. Oh my gosh, I got logged out of my Pearson. My Pearson, why? How dare you? Knowing how to read jump output is going to be a huge help for the test. I'm on the regression analysis finding. Would I include the slope of R or R squared values? Or just, are you doing the project? I would include the R squared is super important to be like talking about, the analysis found that blank percent of the variation in this was explained by this. Make sure to not just copy paste from the report written. So if you're going through the regression analysis finding, great job, Alexander, right there. I probably wouldn't interpret the slope and the intercept. Don't do that. That's like, I think the R squared is most important. Probably say one of the key findings, mentioning it like that's pretty good. Like a key finding from regression was that this percent of the variation in the Y variable of interest was explained by the X variable. This could be leveraged to blah, blah, blah. Make sure every sentence is impactful right there. And don't just reword what they said. I mean, well, yes, reword what they said. Yes. Don't just copy what they said. You don't want to just copy from the report and be like, copy this sentence up here, copy this sentence up here. You want to read it, take it in, and then figure out how to create an executive summary from it, which is going to kind of give the full report. Alexander, thank you for swinging by. Keep asking those questions if you got them. I can definitely answer them pretty quickly here between the sessions. And we are getting a question up that is going to be a jump analysis question. And so let's hear it. We got one. Okay, let's take a look. And this is good right here. This is a connection between some regression analytics with jump and my Pearson. This is how to read jump output for regression. Good practice for the test. Test practice right here. A little chill music on in the background. And so we have right here, the price of a car is what we want to understand. So we're going to make a model predicting the price of a car from the age of a car. That makes age the explanatory variable and price the variable of interest. Makes it the Y. Why do cars sell for a certain price? One thing right here, you'll notice it gives us R squared. Now, you might be wondering, what is the correlation? Correlation must be between -1 and 1. Correlation won't be like R squared where it can be a percent, because it can be negative. You can't have negative percent of things. So correlation must be between the lowest is -1 or 1. Negative indicating direction, strength closer to -1 or 1, the bigger in absolute value. So when we go here, we want to make sure we copy our data to the clipboard. And when we copy it, we'll hit Command-C or Control-C. Very important coming up right here. When you copy data into Jump, oftentimes you will go here. We'll go to File, New, Data Table. Do not click inside the data table. Also, make sure to paste. This one has column names. You can see them over there. What do I mean by column names? Do you see this right here? These are column names. So the reason we are pasting with column names is because we want these column names to go up here into the first column, into the column, not the first column, but the columns. So notice this right here. This is the correct way to do it. Look at how it looks like this. Very correct way to do it. And then this is the wrong way. If you run into this right here where you see that it has the first row with the column names there, don't try to fix it. Just restart. Say, oops, and then say new data sheet, paste with column names. Control-Shift-V right there, but edit, paste with column names. So make sure to do that. So now that we have it pasted with column names, we can actually do a regression on this. To do a regression, we are talking about a bivariate analysis, two variables, y being the variable of interest and x being the explanatory variable. So we want to understand, why do cars sell for a certain price? That's the response we're talking about. And then the age is going to be the factor or the explanatory variable. So we're going to say, does age explain why cars are a certain price? Just follow in that order. Does age explain why cars are a certain price? Does age explain why cars are a certain price? Let's take a look. Looks like they do to a certain extent. And there's a very, very negative relationship right here. You'll notice that it goes down in a mostly linear format. Once again, we can check our conditions. Q, two quantitative variables. Straight enough. Looks straight enough. Mostly a straight line. Here we'll fit a line. Let's look right here. Add line. Little bend. Little bend. Do we have a lack of fit? Good. Lack of fit's a little low, but not too low. That's a different topic for a different day. We're fine on the straight enough. A little bit of an issue. So Q, straight enough. It's straight enough. No outliers. There's no extreme outliers. An outlier would be a point that's far away from the relationship that the data points have. Remember, straight enough and outliers are different conditions. And does the plot thicken? Thickening would be if we look at the plot and it starts to get thicker. And probably one of the best ways to look at plot thickening is going to be a residual plot. Make sure you know here that residual plots are a diagnostic tool. That just means they help you kind of understand what's going on, diagnose what's going on with your data. So we're going to go here to plot residuals to get the residual plot. And overall, it doesn't look like it's thicker. Time allowing, could we do the second part of the Viz 6 write-up? Yeah, I think we could. We could talk about that. You got it. We got 32 minutes. We're doing great. Jenna, thank you so much for swinging by right here. 50 points, Jenna. We'll definitely do that. It's on the list. Let's get it done here in just a moment. So is the plot thickening? I don't know. No, this one is not indicative of any real big problems. Overall, this is a pretty good regression that explains 89.26% of the variation. Here's the mistake people often make, though, is even though we have this r squared, do remember that the line goes down. So 89.3, and then we square root that, and now we need to put negative in front of this because it was in a downward direction. This is because as the age of a car increases, we generally see the price go down. What does the r squared mean? Well, the r squared is found in the jump output right here. R squared is 89.26% of the variation in price is explained by the variation in age. 89.26% of the variation in price is explained by the variation in age. Blank percent of the variation in y is explained by the variation in x. You'll notice right here that we have the intercept, and the intercept is also down here, and the slope, which is next to the x variable. Remember, y equals, and let's write it in here, b0, the slope is negative again, plus b1, and then x. It's in years. So that is the name of the x variable. And the y hat is on this side, standing for predicted y. So the equation is we are predicting price of a car. And then the intercept is going to be this value right here. And the slope is going to be this value right here. So it's technically plus, but it's negative because it's negative. And then the name of the x variable is age. And you can see that up here. So y hat equals b0, which is when x is equal to 0. And look where that's at. 12,302. So it's right there. It's about where it's at. And then the slope is when we see two observations that differ by 1 unit of x, we expect them to differ by blank units of y. And you see here there's a negative slope. So the two cars differing by 1 year are expected to differ in their price by $923, where the car that is older is expected to have a lower price. or for each additional year of age, we'd expect the car price to be $923 lower. I'm rounding those numbers. So pretty good question and good output to understand right here. Age accounts for, because age is the explanatory. So we wouldn't say price accounts for, because we're trying to account for the variation in price. So age explains 89.3%. So I like to say age explains because it's the X variable. Oh, thank you so much, Kayla, right there, helping out. Awesome job, Kayla. 50 points, Kayla, right there. What other factors? Other factors, like there could be more variables, like, you know, the condition, the options, is it a collector car, all that good stuff. Great questions right there. I think Tiffany had another one, and then we can jump to Jenna's question. Awesome work, everybody. Vols have Vols right here. Let's hop to Tiffany's question. Let's go back to the main screen. Great work. Tiffany's question was... Results are based on telephone interviews with 1,008 adults. Let's go check this out. I think this is chapter 10. I know a chapter 10 question when I see it. Chapter 10, results are based on 1,008 adults. Let's go take a look at this. Oh, man. This semester is just flying by. Who else feels like it's like you blink and the semester's half over and you're like, what happened? Where'd the semester go? We were just starting. We're getting towards test 2. And then there's test 3. And then it's winter break. And then it's winter mini term. Ah! Found the question here. I'll be teaching some winter mini term coming up. It's going to be fun here. Everyone's taking their points. Great job. Corey's almost there. Great job. Almost to that one total point. I feel like I blinked and all of a sudden I am taking so many exams. Yeah, I feel like that way too. I'm just giving so many exams. I don't know. Rather take or give exams. I don't know. If you take an exam, you take it, it's over. If you give exam, you give it, and then the real fun begins of all the grading and everything. Yes, but not mad. Oh, that's awesome, Cameron. Cameron, thank you right there for that. Good stuff, Cameron. Just relaxing. 100 points. Meant to give out 50, but you got 100 right there. Let's go check out a survey. Is based on 1,008 adults. Chapter 10, Stat 201. Here we go. I wish I taught a BAS class in winter mini term. I can't imagine doing 2 mini terms. I've never done that. Gotta be careful. Maybe I might try that out, Cora. I teach mini term during the semester, but I've never... Winter mini term is new, and so I've never tried out teaching one... Hey, what's up, Ditto? Yeah, I'd have to check it out. It'd be cool to do that. I don't know if I could ever do 2 mini terms. Very, very... Mini term is like everyone has to focus, because if you don't focus during mini term, it's over in a week or 2, literally, or 3 weeks. So every week is like a... We are focusing. I love it. People do very well during mini term. Just gotta focus. Okay. Speaking of focus, this is a website. A polling company publishes results on a new survey each day. Scroll down to each of the published results, and you'll find a blah, blah, blah statement, including wording. Results are based on 1,008 national adults, 18 or older, conducted on this date, 14 years ago. In addition to sampling error, question wording, and practical difficulties, conducting surveys can introduce errors of bias. For this survey, identify the population of interest. Yeah, I do. I usually do 2 exams. Sometimes I do 3. Do 2 or 3. And yeah, I don't do the visualizations though, because they'd be hit with stuff way too much. I remove the visualizations. It's just it's too compact. They'd be maybe, I don't know. Maybe I'll look over it. It's tough. I tell my students, if you don't work on the class every day during mini term, you might not do well. You're taking a class that's over like 2-3 weeks. That's the point. It's going to be quick. Okay. The population of interest. Who are they trying to understand? The population of interest is going to be who are they trying to understand? They do projects, yep. And so who are they trying to understand? Researchers are trying to talk to 1,008 national adults. That's who they speak to. That's their sample. So who are they trying to understand? Who are they trying to understand? Are they trying to understand the people they call? Well, that's going to be the people they try to speak to. Everyone that responded to the call, well, that's going to be the people who are in their sample. Everyone in the nation that is 18 and older. Sounds about right. Everyone in the nation would include like a newborn baby. So I don't think they want to... What do you think? Goo goo gaga? No. I don't think they're trying to understand everyone in the nation. They want to understand basically adults right here. So the group they want to understand, which is the population, also known as the population of interest. Great job right there, Tiffany, 50 points. The population of interest is going to be the group they want to understand. It's also known as the population. Population of interest just means this is the group you're interested in. Population being the group you're interested in. Interest is just a little salt bay on top of there, a little extra telling you what it means. So don't worry about population of interest or even parameter of interest for the population or population parameter of interest. The company performs its survey by phone numbers generated at random by a computer program. What is the sampling frame? Be very careful. What is a sampling frame? I need a good definition of a sampling frame to start this out. This is where people make mistakes. We pointed this out during class today, that this is where people make mistakes. So what is a good definition of a sampling frame? I need to start out with a good definition of a sampling frame because this one is one where people make errors on this question. I need a good definition of a sampling frame. I need to ask myself, does it qualify as this? So what is a very good... Careful. I need a good definition of a sampling frame right here. I need a very good definition of a sampling frame. Everyone they have access to. So we have to think. Great job right there, Kayla and Tiffany, but let's check. The sampling frame is everybody they have access to. Everyone they could have theoretically sampled. So the ones we have access to talk to. So the ones we could have theoretically, the list of individuals from which a sample is selected, the observations we have access to talk to. So everyone that responded to the call would actually be the what? Be very careful. Once again, this is a tricky one. Everyone who talks to us is now going to be our what? Everyone who talks to us is going to be our what? Everyone who's like, oh, hey, yeah, this, okay, cool, yeah. They're our what, actually. Everyone who talks to us is our what? This is where, like I said, these are some tricky questions. Everyone who talks to us is our what? Is our sample. That's our sample. The people who talk to us will be our sample. Great job right there, Kayla. Great work. That's our sample. Everyone that did not have their phone number generated is just the people we didn't generate phone numbers for. Everyone who had their phone number generated would be the ones that we are probably going to sample unless they exhibit non-response bias. Now, listen to my wording very carefully right here. The people who have their phone number generated are the ones we will probably sample unless they elicit non-response bias. But who could we theoretically have spoken to if we're using some sort of like massive phone number generating program in just multiple universes? If this were to happen again, theoretically, we could speak to who? Theoretically, we could speak to who? Just think theoretically speaking, like technically we could speak to anyone who what? Like who's the people we could, because we're going to generate random phone numbers, so we could speak to theoretically who? Theoretically, who's the people we could speak to? Theoretically, because remember, the sample frame is more theoretical. That's the hardest part about this. It's everyone we have access to, and we'd have access to anyone who what? We'd have access to anyone who what? Because we're just going to generate random phone numbers. We would just, and good answer right there. It is D, because we could speak to anyone with a telephone, but probably if we call someone up and they're like, hi, I'm 15, we're like, I don't know, is that a 15-year-old sound? We'll just be like, oh, cool, we're not going to talk to you. So everyone with a telephone is someone we could theoretically speak to. We're just going to not talk to people if they don't meet our criteria. If we call someone and they're like, there's no over 18, we're going to say, oh, cool, well, we're not going to talk to you. I remember as a kid, they'd be like, is there a person over 18 in your household? Like, you're weird. We need to speak to an adult in the household about this offer we're talking about. Hey, Dad, they're calling about an offer. What problems, if any, would you be concerned about in matching the sampling frame with the population? This is where we get into some problems right here. Not everyone with a telephone is 18 years plus. A little bit. And then I'll go back and talk about that a little bit more, Kale, if you want. Some people answered the call but chose not to participate. That's a bit of a problem. Some people do not have telephones. Yeah, that might be it right there. Some people were not available to answer the call. Well, this might be at random. I'm a little worried. I'm trying to remember if I remember the answer to this one. I would say the issue would be that some people don't have telephones, especially if you talk about like homeless individuals, people who don't have homes. They're not going to have telephones. If we want to understand people who are 18 and older, there are people who don't have telephones. Should be good here. Got that 100. So the hardest one right here is probably B, because the sampling frame is always theoretical. It's anyone you could have possibly talked to. The way this works right here is it's one of those like random number generators that's just gonna be like burp, 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 and then you'll be like, hi, I'm calling you about this. And then they hang up and you're like, okay, another random number. Burp, 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 burp. So does it make sense here, Kayla, that if I have a random number generator that's just gonna randomly generate a number, burp, 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 making random noises, and it generates that random number, then I talk to the person, I could theoretically speak to who? Like I could theoretically speak to anybody who, like anybody who what? Because that's what the sampling frame is. It's anyone we could possibly talk to, and I could possibly talk to who. Not the people I will talk to or I did talk to, or the ones I could have had in my sample from the ones that were generated. But does this make more sense? Anyone who has a phone, and that's a better way. Hale, great job putting it right there. Anyone who has a phone number. That's probably a better way of putting it. Anyone who has a phone number is anyone I could speak to, not the people whose numbers I generate, because those are the people I'm likely to sample because, you know, we did generate their phone numbers, but theoretically speaking, any phone number could have been generated. So does that make sense? That's the toughest part of this one, and that's where the sample frame is usually a little bit confusing, where it's theoretical, and so that one's usually the one that trips people up right there on this question, because theoretically speaking, anybody could have been sampled. A friend of yours in intro class, yeah, let's check that out. Let's do it next year. You got it, Tiffany. I think they're checking out the video. If you're still watching and you want to do visualization 6, let me know. We got a few videos on it, but let me know. We're going to check this out right here. Oh, Tiffany, I already see it. I see it. Let's hop to the main screen right here. What does it look like's going on right there, Tiffany? Do you see it? Do you see what I see? Where's my Batman thing? Batman's gone away. I need to bring Batman back. I do have it on here still. I'm going to do something fun for a second. I have to fix this later then. More work than I thought. So, Tiffany, with the 50 freshmen, 50 sophomores, 50 juniors, 50 seniors, what looks to be the issue right there? And we'll look at this question. What are you doing with the 50 freshmen, 50 sophomores, 50 juniors, 50 seniors? What are you doing right there? We'll do some quickie questions right here. What are you doing with the 50 freshmen, 50 sophomores? And why would it be? Let's hop on and look at it. So the key things with these sorts of questions right here, we're doing some Stat 201 sampling questions right here, is to know your definitions. I can't state this enough that we have to have these definitions written down. I'm going to go through these a little bit if someone's watching this. I'm going to pause on the screens for the different types of sampling methods and kind of let you look at them right here. So please, if you don't have these written down, please pause on these screens and write down these steps. What am I talking about? These steps right here for things like random sample. So I'm just going to pause on these screens. I'm going to say them, and I want you to write them down. So for this first one right here, this is a simple random sample. And with a simple random sample, you are first going to give everything a number and then pick those numbers randomly. The next one right here is a systematic sample. For a systematic sample, you're going to start at a random point and then pick every kth observation. Next, we get to stratified, and we did some examples today. And when you do stratified, you're going to acknowledge a difference between the groups and then sample randomly within the groups. Do not take the full groups and take a certain percentage that is relative to the population. So like if we have in-state, out-of-state students, 70% of our students are in-state. We'd select 140 if we want a sample size of 200. We went into more depth, but write down these steps. Notice, do not take the full group when doing a strata. The last one right here is a cluster. Every time can we go, yeah, let's go take a look at that. Yep. I think we will. We've got 16 minutes, so we got a lot of time. So the last one right here is cluster, and with clustering, there is no difference acknowledged. When you do clustering, you will not be acknowledging a difference. You're going to have things put into groups, and clusters are selected at random, and I cannot state this enough, that doing a census on the clusters. Let me ask you some key questions. You ready? Yes or no to these? Let's go take a look at the main screen. Are we acknowledging a difference between these students right here? Are we acknowledging, wait, was this one different? You sample 50 students to find out the average size of their financial packages. Oh, wait, that's going to be a sample statistic. Cool. I saw 50 and I thought that was the question you were doing. Where is it? Oh, no. Here we go. So with this one, yeah, and basically, yeah, you're on the right track, Tiffany. I wish it said, like, the grades are evenly distributed. So what are you doing by saying we are taking freshmen, sophomores, juniors, and seniors. So we're going to say we're going to take 50 freshmen, 50 sophomores, 50 juniors, 50 seniors, and you're going to take randomly those. But by saying freshmen, sophomore, junior, seniors, you're doing what with these groups? Immediately you should notice this. What are you doing with these groups? Be like, oh, I'm doing what with these groups, which is going to be a key thing for these. So you're doing what between these groups, which is instantly to know, okay, wait a minute, I'm on the track for this one right here. So what are we doing by saying we have freshmen, we have sophomores, we have juniors, we have seniors? I'm doing what between these groups? What is one of the key aspects of one of these that's like, oh, we're doing this to start, so that probably means we're walking down this path. What are we doing? Good way to know. Are these groups randomly put together? And we're acknowledging a difference. But make sure, so both of these deal with groups. So here's the big thing, Tiffany. So 50 points right there, but both of these deal with groups. So we're acknowledging a difference between the groups. We're starting off saying freshmen, sophomore, junior, seniors. These are groups based on differences. The other one is on groups right here where we have random groups where there's no real difference. But so look at the difference, because this is where people get tricked up, because one of them is the groups have differences and we sample randomly within the differences. The other one is we have random groups. Now, yes, no question right here. Are we taking all freshmen? Are we taking all sophomores? Or are we taking all juniors or all seniors? Yes or no? Are we taking all the freshmen? Are we taking all the sophomores? Are we taking all the juniors? Are we taking all the seniors? Yes or no? Only yes or no to that. So are we taking, no, we're not. Great job right there, Tiffany, another 50 points. So that means we are not doing clustering. If we see that a census is performed, that's one of the key ways to know that a cluster is being done. So we're not doing clustering because there is a difference being acknowledged between the groups. So once again, huge thing is that a difference is acknowledged in strata, and then we're going to sample randomly within the groups. We're sampling 50 random freshmen, 50 random sophomores, and then we are supposed to take the population, the percentages based on the population. Assuming that it's pretty even, it would look like this. So this is definitely stratified right here. Is there a similar one? Is there a clustering one? Some of your friends, political science class, angry about a new town restriction. They make an online survey. That's convenience. Putting a survey online is convenient. Don't do that. I mean, you can do it, but it's not going to give you the best, most representative results. Do we have another? Oh, it's the last one. Looking at multiple choice type questions right here. When you sample so that every combination of the individuals in your population has an equal chance of being taken, what's the answer to this? I'm not going to show you the answers yet. But when you sample that every combination of individuals has an equal probability of being taken, so you just say, well, give everyone a number and just draw those numbers randomly. That's the way it's done. And it's described as this way, that everything has an equal and likely chance of being taken. You just put everything in the bag. You say, okay, we got 1,000 numbers right here. Shake up those numbers, draw a number out, put the numbers aside, shake up the numbers. Simple random sample right here. Simple random sample. So that is a simple random sample where step 1, give everything a number. Step 2, choose those numbers randomly and everything. Nice job, Tiffany. Another 100 in the chat right there. Great job, Tiffany. If you create an online survey, individuals can choose on whether they participate in the survey. This is probably going to cause a voluntary bias. Convenience or voluntary, I hate it when we put the two on there. They can choose to do it, so that's voluntary. So that's voluntary bias. You are doing a study for a nonprofit group helping at risk children. Suppose that 14.2% of the children in your city live in poverty. You know this. So is this a parameter? Oh, wait, I'm sorry, Tiffany. Is this a parameter or is this a statistic? You can tell people, Tiffany, be like, you can do it. Yeah, I think so. I think we're looking at that next here, Mohammed. So we'll do that here in, we'll get 10 minutes. We'll do this. Is this a parameter? It says, you know this. It says, you know this about your city. This is something you know about your city. So is that a parameter or is that a statistic? You know this about your city. You know that about your city. Is that a parameter? Would that be the population proportion or a sample proportion right here? Which one of those is that? It's either a sample proportion or a population proportion. You know this about your city. Would that be a population thing or would that be a sample thing? So it's either P or P hat, because we're talking about the proportion of people who live in poverty. So would that be the true proportion of people who live in poverty if you know it? Or would it be the sample proportion? And maybe you should see if we have one of these right now. Which of these would it be? It would be population, exactly. And there's no sample size associated with it. It says you know this, which means it's the truth. Kayla, amazing work. It would be a population proportion, population parameter, which is the proportion is the parameter. Parameter just means what you know. So it's the population proportion, which the proportion is the parameter. Parameter just means what you know. All of these things that I have listed on this slide right now are different parameters, like the true mean, the true standard deviation, and the true proportion are all population parameters, PPSS. Remember that right there. These are over here are sample statistics. If you talk to 100 people and ask them if they live in poverty, then that would be a sample proportion. So that is a population parameter. Does we're going to hop over and do some, we did that one. And I think that's got it. There's the multiple choice right there at the end. Make sure to know the concepts. Let's hop over and do some 474. I'm out of coffee, only drinking 2 cups a day. Don't drink a bunch of coffee. Caffeine on your heart. Good stuff right here. Let's take a look at this. Okay. Question number 2. Oh, and then Cora had a question about the rules, right? Interpreting rules. Before doing, oh, yeah. Interpret the values of lift and support of Ashley Tisdale. Okay, let's take a look. Lesson number 2. I got hints, interpretations from the PDF. Yes. Lots of help, lots of hints, lots of notes. Let's take a look at number 2 for 474. Here we go. So once again, Brian does what $sign. Brilliant. Okay. Brian does similar but different work. Doesn't hat mean predicted? It does. Yep. So that's when we make predictions from models. The hat means predictions. Great job, Kayla, right there. So Brian does similar but different work right here. And we're going to calculate, by calculating and coming to the probabilities of finding by him before and after knowing. Yes, okay. So that both, okay. We need the rules. Here's where we're creating the rules. So got a rule. Okay. Let me go and make my own set of rules. Okay. Brian's going to remember how to do this from memory. You ready? Here we go. Rules save into a priori. And the a priori takes the data frame we need. We need parameter equals a list. And support. I'm doing my own rules. I live by my own rules. Brian does similar but different work. Be very careful. Not doing this work right here. Building my own rule set. Support going to be at least 250 out of the total this right here. Similar but different work. We'll put the parameter on its own line. The list right here. And should be confidence. Let me just run this, see if it runs. It's going to give the extra output too. That's fine. Okay, it ran. I'm going to go down here to the control. The control is also a list. Just means you can put multiple things. Verbose equals false. Good, that worked. The verbose just removes the extra output, so you don't want to knit that stuff. Yeah, I wouldn't knit that. It just removed that extra output. There we go. Those are the parameters it's using by default. And we can see right here, there's the support. And this is the support I calculated for it, 0.137, right there. 0.137. There's better support. And now let's go right here. Let's add in a conf. And I think it's showing me how to spell those, right? There goes confidence. I don't know. Sometimes it's conf, sometimes it's confidence. Who's ready for the... Finch knows what's up. And the confidence is currently set to this by default. I didn't even know how to default. Let's go here to 85% confidence. Yeah, it's pretty cool. You look at what it says and... So you can look at the parameters you're using right here. Nice. Min-val, got a max length of rule this. We probably don't want our rules to be this long. So let's go here to max len. Thank you for helping me spell these things. Max length, and now it's going to do a min length. Mining stopped. Only patterns up to length 3 returned. Cool. And that's because we have the extra stuff up here. And let's go move this over a little bit. Let's go to min length equals 2. I wish those had autocompletes. Let's turn off the extra output and we're good to go. So now we've created a whole bunch of rules. What are rules? Let's take a look at some of our rules. When we go to inspect on the rules, it'll give us all the rules. We've created 51 rules right here. This tells us that if somebody listens to, and you know what, let's make it easier. This tells us if somebody listens to Rihanna, how it impacts them listening to Lady Gaga. This is a little bit easier in interpretations of rules right now. So this is if somebody listens to Lady... That's a weird number. If somebody listens to Rihanna, how does it impact them listening to Lady Gaga? What is the support right here? So what does the support mean? What does the support mean? And I will show you mathematically. In the chat right now, no, we've only got a little bit of time left. Who knows what the support means of a rule? Be able to understand and interpret what the support of a rule means. What is the support of a rule? What is the support of a rule? The support of a rule, and this is different than support of an item, which is from item frequency. The support of a rule, not that it increases, the support of a rule is going to be 21.1% of people have Rihanna and Lady Gaga in their playlist. So I'm using this code right here to show 21.1% of people have Lady Gaga and Rihanna in their playlist. Now the confidence is for only the people who have Rihanna. What's the probability they have Lady Gaga? So if we went here and did a subset and did the following, so let's make a subset. We're just going to show this to be true. So all we're doing right now is proving things. We love proving things in statistics and mathematics. So here we go. And if we go here and take only the people who have, Rihanna. So 446 people have Rihanna. And then we go right here, and from this, we do an item frequency of this subset. So now we're looking at what these people have in their playlist of only people who have Rihanna. What percent of them have Lady Gaga? And take a look. This is this number right here. If it was Rihanna, Fleetwood Mac on the left and Lady Gaga on the right, it would be 20% of people have all... Exactly. If it's a longer rule, it's what percent of people have all of this. Does that make sense what a support is? This support is for all the items. If it's a longer rule like this right here, this support is 18% of people have all three of these in their playlist. Not like you have one of them, not like you have a combination of them, but you have 18% of people have Britney Spears, Lady Gaga, and Katy Perry. But if somebody has Katy Perry and Lady Gaga on their playlist, then 88.1% of them will have Britney Spears. Does that make sense, Cora? If somebody has Katy Perry and Lady Gaga in their playlist, then there is an 88.1% probability. Or a second interpretation, hints. A second interpretation would be the combination of Katy Perry, Lady Gaga, and Britney Spears is observed 88.1% of the time compared to what we would expect by random chance, or a factor increase. So I should say that. The factor increase, interpreting lift, sorry, my brain broke. Second way to interpret the lift right here would be the factor increase to the probability of Britney Spears. Resetting my mind. Let me go through in order. Brain's just not working today. The coverage, and then we'll get to lift here in a second. The coverage is going to be the support of the left-hand side, which we don't really do a lot with. So if we looked here of how many people have Rihanna, we actually just saw that a moment ago. The percent of people who have Rihanna, that's what the coverage is. So we could actually find that. We did some work earlier. We just take right here the length of how many people have Rihanna. So this is just showing what this is. Just know what these terms are. So the coverage right here is literally what percent of people have Rihanna. And notice that that is the coverage. It's the percent of people who have the left-hand side. So it's the support of the left-hand side of the rule. Now, the last thing to talk about here, which Brian's brain just broke on, is the lift. And let's talk about the two ways to interpret the lift. Hint for your assignment. Now I'm getting serious. One way to interpret lift is that given somebody has Rihanna in their playlist, or whatever's on the left-hand side, the probability of Lady Gaga increases by a factor of 2.7. And let's show that mathematically. The probability of Lady Gaga was originally this. So the probability of Lady Gaga was this. And now the probability of Lady Gaga is going to increase by a factor of 2.70 to 86.1. Notice that when you times the original probability of Lady Gaga by the lift, you obtain the confidence. So Lady Gaga's probability, given Rihanna's in the playlist, has increased by a factor of 2.7. So one way to interpret lift is, given the left-hand side of the rule is there, given that Rihanna's in the playlist, the right-hand side increases in its probability by a factor of 2.7. And you can see it mathematically right here. The original probability of Lady Gaga was this, and now it's increased by a factor of this to a new probability of the confidence, which means given Rihanna's in the playlist, we have a 86.1% confidence that Lady Gaga will be there, the new probability of Lady Gaga after we follow the rule. The other way to interpret it, way number 2, which my brain broke on for a second, would be the combination of Rihanna and Lady Gaga are observed 2.7 times more than we would have expected via random chance. Once again, that was the combination of Rihanna and Lady Gaga are observed in playlists 2.7 times more than we would have expected via random chance. This goes into the way to calculate it with Bayesian mathematics. We'll probably review that a little bit during class tomorrow. But that right there talks about the probability of the two being observed versus what we would have expected via random chance. And we could actually calculate that. That one's a little bit more complicated to calculate here. I'll calculate it here for you. So if we were to calculate this by random chance, we need the probability. And funny enough, this is stat tool 1 again. So we need the probability of Rihanna times the probability of Lady Gaga. So this right here is the probability of both Lady Gaga and Rihanna. So this is the probability, and it's just the mathematics rule of independence. We're assuming independence. So this is what we would expect via random chance. So we could put this right here, random chance of 2. And so that's the random chance of the two of them occurring by random chance, because we're just multiplying the probability. Lady Gaga has this probability, Rihanna has this probability. Assuming that they're independent, then we would expect them to occur 0.078 times together. We're going to grab a code we wrote previously today, and we're going to see what percent of the time they occur together. And so now we'll say occur together. So this is the actual amount of times they occur together. So these are the playlists that have both in here. And the playlists that have both in here, it's in getting weird calls today. They occur together in 21.1% of playlists. So all I need to do is take these two numbers, and I could do it this way. The percent of time they occur together, or we would expect via random chance, is 2.7. And take a look. That is the lift right here. So they occur together 2.7 times more. The combination occurs together 2.7 times more than we would have expected via random chance. You can read it as the rule where given Rihanna's in the playlist, Lady Gaga appears 2.7 times, like her probability increases by 2.7 times, or the combination of the two of them, or it could be 3, occurs 2.7 times more than we would have expected via random chance. So I did the random chance calculation right here, doing the mathematics, assuming independence on the two. And then I did the calculation of how often do they actually occur here by taking a subset of how many playlists just have those individuals. Does that make sense, Cora and Mohammed? A little bit quick on the end right here, but showing mathematically the way we can get the calculation of how often do these two occur together, and then what would we expect via random chance, and then the ratio of these two is going to be the lift, or it's one way to talk about the lift that. And this is the value of lift. So the combination of Rihanna, Lady Gaga occurred 2.7 times more, like a ratio, a factor increase of 2.7 times more than we would have expected by random chance. Also, the other way of looking at the lift, once again, is to say Lady Gaga is listened to, where's my Lady Gaga thing? Lady Gaga, awesome. Lady Gaga is listened to this percent of the time. So knowing that Rihanna's in the playlist, then it increases the probability of Lady Gaga being in there by 2.7, and you see now the confidence. So understanding this right here, how these values are connected, is very important, and that's got it. That's the end of class right here, or office hours. Great review, good stuff. Know the output, know how to read it. This 384 stands for there's 384 playlists that have all of these. That is relative to this. So decimals not be carrying out on that. Where's my decimals? Ooh, decimals, what you doing? I want some more decimals on that. Well, that's got it. We'll be back here. Swing by class. I'm going to send out the announcement. See you in class soon. Bye. Great job, everybody.